So in this case, we are going to consider a revision, which is important as we are preparing for our June control tests that we are having from our different provinces. So in this case, we are going to consider the Free State province, which is also, this was a June mock test that they wrote in 2024. So we are going to go through the questions and see how they were given the questions, right? So if you are of the Free State province, you might have similar or exact questions. In most cases, these questions they do repeat. That does not mean if you are from the other province, you're not supposed to revise these questions. You are supposed to go through these questions also, so that you can understand also as an individual how these questions are being given. It is very, very important that we do understand because these questions, they are similar. All right. So going through our instructions, remember your instructions, guys. Do not forget to go through these instructions. Read every instruction. It is for you. So I'm not going to waste your time, guys. Quickly, on question number 1, we were given, so which of the following that we are given numbers that is in a number pattern or in the following sequence as you see it. The numbers are being arranged. So they are asking us on these numbers that are being arranged, which are the two missing numbers in the pattern below? Which are the two missing numbers? How can we notify the missing numbers? We have to study the pattern first. What is happening between these numbers from the first number, which is 3, going to 9, to the next number that we do not know, to 8? What was happening? That is the question. All right. So let us study properly, guys. We are going to notice that from the first number to the next one, we were actually multiplying by 3. In actual sense, this was going to be a difficult situation, especially under an exam where we are given two numbers here. All right, because I can say, okay, I choose a constant difference. I find there's a constant difference. But I have to test now to say, is that the same constant difference that is going to happen to have this one? All right. So it was a tricky part because it was going to waste your time. In which manner is it going to waste our time? In this manner, guys. We are supposed to be given at least 3 numbers that we can work with to test in the number pattern that we are given or in the pattern that we have. Do we have a constant difference or a constant ratio? You see, it will be easier if there are 3 numbers than when there are 2 like this. You can't tell, guys. All right. So what can you do? You can work with the answers. If it's up to you, that one, you can work the answers, test with answers. But like I was saying, also looking into these numbers, these are numbers also that we are used to. That is why you see they just gave you 2 numbers there. 3, 9, 81. Guys, there's something about a 3 there. Look into the exponents of a 3. 3 to the exponent of 1, which is 3. 3 to the exponent of 2, which is a 9. 3 to the exponent of 3, which is 27. 3 to the exponent of 4, which is 81. 3 to the exponent of 5, which is 204. You know these. You are used to. You can easily tell what was happening. It can be any of the perfect squares. It can be even 2, 4. They leave another part where we're supposed to have an 8. Then they move on to 16 and so on. They give you this. They leave another part. They can do that on the squares because you are used to that. So it's not every pattern where you're supposed to expect a simpler presentation, you're supposed to get used to this condition. All right. So in most of these conditions, they are testing you on squares of numbers. They want you to understand the squares of numbers. As an individual, I advise you to go through each and every square, at least from 1 up to 9, even up to 10, guys. 10, at least know these. 1 squared, 2 squared, 3 squared. You know every number. It can help you, right? So that is what is happening in terms of the numbers, not just the squares, but numbers being raised to certain exponents, certain powers. All right. So, guys, I've wasted a lot of time. I thought that I'm not going to explain much. But, anyways, let's see. So, meaning to say the answer here was going to be what? 27. As we can see, 3, 9. Then we go to what? To 27. So, that is 27. 3 to the exponent of 3. This is the first term, second term, the third term. So the third term, but we are using 3 as our base. So it's 3 to the exponent of the term, third term. All right. The same 81, it was 3 to the exponent of 4 is the fourth term, meaning to say on the fifth term, 3 to the exponent of what? Of 5, which is 243, just like that. So these are the numbers. So the best answer was going to be A, where we have got 27 and 243. So that is what was happening. Or like I was saying, if you can simply analyze, you can see that it was just a multiplication by 3. From 3 to 9, multiplied by 3 to get this. So 9 times 3 is going to give us what? 27. We multiply 27 times 3, that's 81. So 81 times 3 is what? 243. That was another way that you could have obtained those numbers. So guys, as you can see, these questions, you play around the way that you want. Which of the following is irrational? Let's start by the rational. A rational number is the one that can be expressed in the form of A over B as a fraction. Meaning to say, if we cannot express it this way, it is an irrational number or a non-real. A non-real, we're talking about numbers that do not exist, such as the square root of a negative number. All right? It do not exist. So we have got the square root of 25. We know this is 5. 5 is same as 5 over 1. So that's a rational number. So meaning to say it cannot be an irrational number. All right. The square root of 1 is 1 and 1 is same as 1 over 1. Meaning to say it's a what? It's a rational. So it cannot be an irrational number. What about the square root of 23? Do we know this? No, that's an irrational number, an endless decimal. When being simplified, the square root of 23, guys, look, it cannot be simplified. That's an irrational number. Expressed as a decimal, an endless decimal. The calculator can only give us the values that it can accommodate. Otherwise, if you're using another type of a calculator, it will show you different presentation in terms of the numbers that it can carry. So that is it, guys. That is it, guys, on this part. So the answer was going to be D. All right, 1.3, the property demonstrated below is. So for us to know these properties, we're supposed to understand what is on our answers, what is an identity property. Remember identity property, as this is under addition. Identity property of addition, we know that if we add A plus S0, it's going to give us what? A. Is it what is happening? No. So identity is total out. Associative property of A plus B in a bracket plus C is supposed to give us A plus B plus C like this in a bracket. So this is exactly what we can see. There's a bracket of these two numbers, -7 and 4. But if we check now, it's on the other side where we are given the 4 and also, all right, so this one was just a mistake to say it's -8. It's -8 like this, like as it is here, all right? So here they're not testing you guys on the numbers too. The presentation is the one that you're worried about. So they just made a mistake that it's minus what? -8. So you can see that it is exactly what we have here. This is A plus B in a bracket. then plus C. But if we check on this other side, A is now on its own. Don't mind that bracket. The bracket is following the negative. Remember, a -7, we just put it in a bracket. So don't mind that. So this is our A separate. Then the B and the C are being combined in one bracket like this. So as you can see, guys, this is exactly our associative property that we are going to need on this 1.3, all right, of addition. So it's associative property of what? Of addition, all right? So what about commutative property? The commutative property of addition states if I add A and B, it must be the same as B plus A. So as we can see, we don't consider bracket. It's just like 2 plus 3. We can start with 3. So it's 3 plus 2. So guys, it's not that one. This is totally out. Distributive property. Remember, the distributive is when A is multiplying a bracket where it multiplies everything inside of the bracket. So it's A times B, A times C. So we can see that this is not what we are given there. So the distributive property is totally out again. So that is how we can also tell. So the correct answer that we needed there was going to be on B. Then on 1.4, simplify. On this type of equation, guys, just simplify. Then you check which answer there corresponds. All right. So we have got y to the exponent of 5 raised to the exponent of 4 times y to the exponent of -2 to the exponent of -5. Everything over y to the exponent of 5 to the exponent of 6 like this. All right, so let's figure out. Laws of exponents, we do understand when x is being raised to the exponent of a and to the exponent of b, we can multiply the exponents together, a times b. So that is the condition here, exponent to exponent. So that was going to be y to the exponent of 5 times 4, which is 20. The same thing, the -2 and the -5. You multiply these two, -2 times -5, that's to the exponent of 10. Everything over the same thing, 5 and a 6 multiplied together, that's a 30. All right, so we multiplied exponent to an exponent. That's the law. Exponents, you work with laws. But as we can see, we have on the numerator, the y on its own, another y on its own, multiplied together. So what are we going to do? We are supposed to use the law. X to the exponent of a times x to the exponent of b. What do? We add exponents because we are multiplying bases which are the same. So this was going to happen. We're going to add our exponents. In this case, we are talking about what? A 20 and a 10. We add these together. So it was going to be y to the exponent of 20 plus 10, which is y to the exponent of 30. So we are going to have y to the exponent of 30 from the numerator. What about the denominator? There is y to the exponent of 30 already. All right, so this is what we have. Guys, this is a mathematical presentation. You can even cancel. These two are the same. So they can cancel a over a gives us what? A 1. It's a property that you need to know also. So by just looking into this, we know that our answer is 1. All right. But let's say I didn't recognize that. I still want to use the laws of exponents. There are people like that. Still want to use the laws of exponents. So what do? There's a division this time. Dividing the bases which are the same will make us to subtract the exponents. A minus B. Remember your laws. So it means you are going to subtract y to the exponent of 30 minus 30. 30 minus 30. So 30 minus 30 is what? That's a 0. So we know any number to the exponent of 0 is what? A 1. As we can see, canceling that to get a 1 using the laws of exponents, we still get the same answer. So the answer in this case was going to be 1, which is on A. So that was it on this question. We just needed to know our laws of exponents. Laws of exponents. Even without the laws of exponents, by just investigating your questions, guys, some of these you can just cancel them out. You see, okay, this one can happen like this. All right, on 1.5, we are given how many terms do we have in the expression, this one that we are given. So this is our first term. Take note, this is a bracket, guys. So it makes this to be a single term because of a bracket. So meaning to say we've got two terms. Yes, we can even expand the brackets, then simplify. We'll see that at the end, you were still going to have two terms at the end. So the correct answer was going to be B. All right, 1.6, write this part in a more simplified form, mathematical conversion. More simplified. Guys, we are going to simplify this. This is a bracket. Remember your body mass. Your body mass. Brackets off. So we've got brackets here. 4 plus 3, which is 7. So it was going to be 7 times n times m. These two. This gave us a 7. But in a more simplified, or in just a simplified, we could have, okay, guys, if you're multiplying 7x, 7 times x times y like this, I just multiply and have 7xy. Someone can write 7yx. Someone can write xy7. Someone can write yx7. All these answers, they are correct. But when now the question is specifying to say, let it be more simplified, it means it is not just a simplification that they need, but it must be more reasonable in our mathematical presentation. So we do understand, yes, we start with a number, which is 7, followed by the letters. But these letters, if we are now into a situation where we look into them, we also follow the alphabetical order. It is no longer just NM. No, we have to start with M followed by N. So that was going to be the situation. So the best answer must be 7MN, 7MN, which is on C. Number 1A, the 1.6A is not wrong. B is not wrong. D is not wrong in terms of just a simplification. They are all correct. But when we go to this statement where they said more simplified form, more, this one becomes the best answer. All right. So that is it, guys. Let's move on to another part, which is on 1.7. What is the coefficient of x in this expression or in this term? As you can see, it's just a single term. What is the coefficient of what? X. Guys, the coefficient of x, if you're given 2x like this, we cover that x like this. We take everything that surrounds the x. That becomes the coefficient of x. Everything that is surrounding x. So in this case, it was going to be a 2. The coefficient of x is 2. So if it is 2xy like this, if we cover that x, what is the coefficient of x? The coefficient of x becomes 2y. What surrounds x? It's 2 and y. So it becomes 2y. That's the coefficient. What about on this fraction of minus x over 4? If we cover our x here, what is it that is left surrounding that x? That becomes the coefficient. So take note, there is minus what? Minus 1. If the number is not given, it's minus 1. So meaning to say there's a minus 1 on x and also a 4, which is on the denominator. So minus 1 over 4, which is part of x, becomes the coefficient. So the best answer was going to be D. What surrounds x? If you cover it, what is it that you see left aside. All right. Moving on to 1.8. If we are given this equation, then Z is equal to what? They are just like solve for Z, not for X, but for Z. Most of us, we think when it is an equation, you are supposed to see X, 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 always X. No, it can be B, it can be A, it can be M, it can be a Z also. The same way that you could have solved this equation when it was 2x into x minus 5 is equal to 0. Let it not change because now there is a z. Then you are now confused. You say, I don't know how to solve this equation. No, guys, don't do that. Understand that x can be replaced by any letter. Any letter. All right? So 2z into z minus 5, when it is equal to 0, what does it mean? It simply means one of these. Remember, the zero product. One of these must be equal to 0. I take this, I equate it to 0. I take the other bracket, I equate to 0. That's the case. So it simply means, therefore, 2z is equal to 0. 2z, we take it to be equal to 0, or the other bracket, we take it to be equal to 0. That's it. Z minus 5 is also equal to 0. So let's solve for Z. This one is a product, so divide by 2 both sides so that they can cancel. So Z is equal to 0 divided by 2. That's it. 0 there. All right. So be careful on dividing, guys. You can even use your calculator. 0 over 2 is what? That's a 0. Okay. Let's move on to another part, which is the Z minus 5. So taking the minus 5, it's a linear equation, this one. So the minus 5 can jump the equal sign, or it can cross the equal sign. The moment it crosses the equal sign, it changes its sign. So it was a minus, it will be a plus. So therefore, Z will be equal to 0 plus 5, which is 5. So we need the answers 0 or 5. So which one is the best? 0 or 5 is on what? Is on C. So that was going to be the best answer for this question. 1.9, what is the additive and multiplicative inverses of minus 10? There are two inverses being asked there. The additive, the multiplicative. So the question is, when we talk of the additive inverse, what is it that we are considering? The additive inverse, let's start with that one. The additive inverse is a condition, or we can put it in algebraic form, where if I add x to minus x, I must get a 0. Meaning to say, one of the numbers must be a negative. One must be positive for us to get a 0 if we are adding. So it means if I start with minus x, I must add what? Plus x in order for us to get a 0. This is the additive inverse. So let's start with the additive of minus 10. So it's minus 10 plus what to get a 0. When it is minus x, we must add x. So we must add what? A 10 here to get a 0. Minus 10 plus a 10. The same number, guys, it only changes the sign. So when it was a 10, the additive inverse of a 10, you just put a negative, it will be minus 10. So if they give you minus 10, you put a negative on minus 10 like this. You put a negative, minus is what? Becomes a positive. All right? So meaning to say, the additive inverse of minus 10 is what? A positive 10. So on the additive inverse, we have got a positive 10. All right, let's move on to another. There are two inverses that we are given here, guys. Do not forget. The other one is what? Multiplicative inverse. What is it about the multiplicative inverse? The multiplicative inverse states that if I have x, then I multiply it to 1 over that same x, this one. The same number that was here, I use it in the denominator here. If I multiply these two, I must get a 1. So it simply means if I have a minus 10, what must I multiply with to get a 1? It must be 1 over what? That same number that is here must be here. If it is x, this must also be x. So if it is minus 10, this must be minus 10. So if it was 10, the multiplicative inverse, if this is 10, it must be 1 over 10 to give us a 1. So when you put a negative, this must be a negative also. So it's negative here. But we know when writing the numbers, guys, we cannot write like 1 over minus 10. The negative goes up. So it will be minus 1 over 10. All right. So that is our condition, guys. Meaning to say the multiplicative inverse of minus 10 is what? 1 over minus 10. But like I said, 1 over minus 10 is the same as what? Minus 1 over 10. So these are the answers that we want, guys. The first one must be 10 for additive inverse. The second one must be minus 1 over 10 for what? Multiplicative inverse. So answer the questions properly. There were 2 questions that were being asked there. So which one goes first? You follow the order. So additive, we said the answer is 10. Multiplicative, minus 1 over 10. Which one has got that? That is here, 10, and supposed to be end here because we're dealing with two things. This one and this one, not or. Supposed to be end here, end. All right? So that is it. So meaning to say the best answer was going to be C, where we've got 10 and minus 1 over 10. So moving on to 1.10, what is the constant term in the expression? This expression, what is our constant here? The constant is where we do not have these letters, F, G, whatever that we have. So the constant is what? Plus 10. Plus 10 is where? On A. So that is our correct answer, 10. Question number 2. State whether the following statements are true or false. 2.11, 2,143, and so on and so on. Take note, they are saying and so on, it's still going. Is an irrational number. That's very correct because we do understand that an irrational number is an endless decimal. All right, 2.12, the cube root of minus 8. Guys, this is, even if you do not know, use the calculator. The cube root of what? Minus 8 is what? You can see the answer is minus 2. So is minus 2 non-real? No. It exists, guys. A non-real is something that does not exist, something that we cannot simplify on our calculator. Like the square root of minus 8. This one does not exist. On your calculator, it must write met error like this, meaning to say this does not exist. But if you can simplify the square root of 25 and you see an answer like this, as long you get an answer, whether it's a decimal, the square root of 3, as long there's an answer, that number is a real number. That makes it to be real. So meaning to say, non-real, guys, cannot be. It becomes a false. This number minus 2 is what? A real number. All right. So 2.2, use prime factors to determine the cube root of this. They don't want you to take your calculator and find the cube root of 4096. Then you say, I can have this one. The answer is 16. No. They say use something to do that. What is it that they want you to use? Prime factors. So guys, how do we use prime factors to find this? All right, let's go to our prime factors. The prime factors of 4096, this is the number that we are given, 4096. So some of you guys are wise, you can use your calculators, but here they want us to show working because, guys, 4 marks. So remember your ladder that we have, dividing by the smallest prime number, prime factors, prime numbers, 2, 3, 5, 7, 11. These are the prime numbers. So the first one, we're going to start with 2. So you're going to see 4,096 divided by 2. There you can use your calculator, guys, to just divide 4,096 divided by 2. You get 2,000 and what? 48. You do the same thing up to the last one. All right. So this was going to give us 1,024. We do the same by 2. 512 by 2 was going to give us 256. This is your calculator, guys. Do not even worry here. You can use your calculator. By 2, we get 64. By 2, 32. By 2, 16. By 2, 8. All right. So here, by 2, so it's going to be 4. By 2, it was going to be 2. And by 2, it was going to be 1. Until we get a 1 here. So these are the numbers, which is actually the number 2, is multiplying itself how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times. 12 times. 2 times 2, 12 times. What does it mean? It simply means that's 2 to the exponent of 12. So where we see 4,096, we simply see 2 to the exponent of 12. And when it is written like this, it is easier for us to find the cube root. Why? Let's go back to our simplification. So it means the cube root of 4,096 is the same as the cube root of what? Because the same 4,096 is same as what? 2 to the exponent of 12. How do we determine the cube root? Guys, I told you, under mathematical presentation, if you are given x, let's say this is what you're given as x to the exponent, it is the 8th root of x to the exponent of b. I told you guys, to get rid of this condition, take the exponent here, divide it to the number that is inside of the root. So it will be x to the exponent of b over a. Yes, it's a law that we have from our laws of exponents. But for you not to get confused, guys, this is the easier way. Once you see this, you take the number here on the exponent, the 12 that you see there, divide it by what? By 3. Just that the number inside the root sign, the number that is inside the root sign. Once you do this, guys, you're done. So it was going to be 2 to the exponent of 12 divided by 3, which is 4. What is 2 to the exponent? 4, you multiply 2 times, 4 times. It was going to give us a 16. As we can see, same answer as what we got previously, but a way that was used is a bit longer. And that is what they wanted you to do. Use prime factors. So you follow the instruction. That is an exam. All right. On 2.3, the ratio of boys and girls is 4:9. So as we can see, guys, they're saying for every 4 boys that we see, there are 9 girls. This is the ratio that we see. A ratio is something that is mathematically proven. A ratio. So meaning to say, in a normal consideration, where we see 4 boys, 9 girls are there. That is the condition of the question. The ratio 4:9. Then the question further on says, if there are 54 boys who corresponds to this ratio of a 4, how many girls must be there? So it's just like a proportion when it is like this. To say, according to ratio, boys, they are 4. According to, guys, understand my language? According to ratio, boys, they are 4. But numerically, the way that we are given, they are not 4. They are what? They are 54 boys. So it's a ratio here that we are dealing with. Then this is the exact number. So 4, according to ratio of boys, corresponds to what? To 54 boys. The number of boys that are there, they are 54. So using the same, if we check 9 as a ratio of girls, how many are they? We do not know. Simply, there must be more. 4 is less. 9 is more. So it means we must have more girls this side. What type of a proportion is that? It's a direct proportion. A direct proportion is where it goes in the same manner. Less corresponds to less, more corresponds to more. It's a direct proportion, that one. So meaning to say, we can find the value of x by just cross multiplying, understanding our direct multiplication. It was going to give us 4 times x, that's 4x is equal to 9 times 54. So you're going to multiply whatever that you have, 9 times 54, 9 times 54, which is 486. So that's 486. So 4x is equal to 486 divided by 4. Remember your equation. You're going to have the value of x. So this was not going to make sense. Let's just divide by 4 and see. We're going to get a decimal, 121,5, which is not proper. We cannot say we've got 121,5 girls. If you're dealing with the number of people, we must be dealing with what? Whole numbers. So it was according to the values that were given. That is the answer. No, guys, this is the answer. That is what you're having. But the values they gave us, they do not make sense because we're supposed to have proper values. We can just approximate to the next value to make it 122, a whole number, not a decimal. We cannot say 121,5 cups or chairs. We talk of whole numbers when you're referring to something that we count. All right. So that is it on this part. All right. So that was a simple or a direct proportion to be followed in this manner. Question number 3, consider this pattern: -1, 1, 3, and so on and so on. Write down the next term. All right. What is happening here? From -1 to 1, we can see that there is a difference of 2. We can even -1, this is 0 here, this is 1, this is 2, this is 3. From -1 to 1, we move 1, 2. All right. From 1 to 3, 1, 2 again. So what about 3? We're going to move 2, 1, 2. So that's 4, 5. The next term was supposed to be a 5. But how can we tell properly here? This is just normal, guys. I told you that when you are given 3 numbers like this, you can tell, guys, there's a constant difference or ratio. By just looking, the constant ratio cannot work. This is 1 and this is 3 and 1. The constant ratio cannot work. So let's check the difference. The difference, this is first term, second term, third term. Remember, constant difference, T2 minus T1. So we take the second term, 1, minus the first term. The first term is what? -1. So use your calculator. You're going to get a plus 1 plus 1, which is what? Which is 2. So there's a difference of 2 here. You do the same thing. Third term minus the second term. Third term minus the second term. So it means 3 minus 1, which is a 2. So as you can see, we are having the same difference of a what? A 2. We know when there is a constant difference like that, it means we were adding -1 plus 2. Then we got a 1. 1 plus 2. Then we got a 3. So in the same manner, 3 plus 2, what are we going to get? A 5. So the next term there was a 5. Write down the constant difference. Already we talked about that. So the constant difference is 2. Then 3.13, write down the general rule of the pattern in the form Tn. Remember, I talked about this on the introduction, so make sure that you go through the number patterns. All right, I said whenever you are given a condition where you've got a constant difference, the general rule Tn is given as Tn is equal to the constant difference in this case, which is what? Which is 2 times n. So it's 2n constant difference times n plus what? What must be added here to give us what is corresponding in those terms? So what is it that must be added? So the 2 is the constant difference that we see here. So how do we find this part, the missing part? We can use any term, first term, second, third, and so on and so on. So as for me, guys, I always work with the first term. T1 is equal to what? T1 is equal to minus 1. So if T1 is equal to minus 1, what does it mean? It means we say Tn. So n is 1. Where we see n, we put what? A 1. But that Tn is what? Minus 1. So it means in place of Tn, you're going to have minus 1 is equal to, in place where you see n, T1, the first term, n is 1. So where we see the n, we are going to put a 1 there. So we substitute a 1 plus what must be added. What is it that must be added that we do not know? We have to find it. All right, so let's find it, guys. Minus 1 is equal to 2 times 1, which is 2, plus what must be added. We take it to the other side. It was going to be a negative minus 1 minus 2, which is minus 3. So meaning to say minus 3 is that part which was supposed to be added. That part that is supposed to be added. So therefore, our Tn is equal to what? 2n plus what must be added is minus 3. So remember, plus and minus will give us what? A minus at the end. So that is it. What must be added to this part is minus 3. So that was going to be our condition. So guys, they do ask these questions. Be familiar with this. Go through the introduction. I told you guys when I introduced or talked about the ATP that they are going to go back to term 1. Never neglect what you did back in term 1. All right? Which term in the sequence is equal to 47? They are simply saying when Tn is equal to 47, so n is what? The nth term. We are finding n. Remember, this is the general rule. The representing Tn. The same Tn that we see is now said it is 47. So what are they saying? We simply equate this Tn that we see as an expression to the Tn that we see as a numerical value, which is 47. These two, they represent the same thing. So as we can see, we formed an equation where we need to solve for n. So find n. All right. How do we solve n from our equations from grade 8? Said we're going to take the minus 3 to the other side. It jumps the equal sign. It becomes a positive. So that's 47 plus 3. 2n is equal to 47 plus 3, which is 50. So we can simply divide by 2. All right, since this is a product here, so divide by 2. That means our n was going to be 25. So meaning to say that's the 25th term that we are talking about, which is equal to 47. So this is how these questions are given. 3.2, consider the number pattern below. They are saying 3.21, determine the number of unshaded squares. So it's not about this part which is shaded. No. It's not about the part which is shaded. It's about what is not shaded. How many do we have? For the first one, it's 1. The second one, there are 2. The third one, there are 3, guys. So it's just like, what can we say? 1:1. 1:1. The first one is 1. The number of unshaded, if we talk of the pattern to say the number, then the number of unshaded squares, it's 1. If we move on to 2, it's 2. It's 3, it's 3. It's 4, it's 4. That is what it means, 5 and 5. It's a 1:1, because 1. So the question was determine the number of unshaded squares in diagram 2000. Guys, that's why they are giving you these bigger values, because they know if it is 1, it's 1. If it is 2, it's 2. If it is 3, it's 3. So what about if it is 2000? It means it is going to be 2000 also. Whatever, guys, that is corresponding, the term and the number of boxes are equal. Even here, when they say which diagram will contain 1000 unshaded, if we have got 1000 unshaded squares, it means we are talking about which diagram? The 100th diagram. 100th diagram that we're talking about. I mean, 1000 that we have, because it's corresponding 1000, 1000. That is the condition that we have. So diagram 1000 must have 1000 unshaded squares. Since diagram 2, you've got 2 unshaded squares. Diagram 3, you've got 3 unshaded. Diagram 4, 4 unshaded. So that does not change the case. So 5000 must be 5000 also. All right. So question number 4. Calculate the following without using a calculator. They do not want a calculator this time, meaning to say all working must be shown. So 4.1, we are given minus 25 in brackets plus a 40, all right, minus a 5 in a bracket minus 32 like this. So how can we simplify? Remember, your board must get rid of the brackets. So here, guys, there's nothing that is affecting. It's just like 1 times minus 25. So it was going to be negative 25 plus a 40 minus and 5. It's just like minus 1 times 5. That's minus 5 minus 32. So we can simplify whatever that we can in whatever manner that you want or that you understand. It is up to you from here, guys. Whatever that you want, whatever that you understand. Minus 25 minus 5 gives us a minus 30 plus a 40 minus 32. If we take here 40 minus 30, it's a 10. So we've got 10 minus 32, and 10 minus 32 is just like 32 minus 10, which is 22. That is a negative. So it's minus 22. We can even use our calculator, guys, at some other stages. When they say do not use a calculator, they are simply saying do not take the calculator and simplify everything at once. But these stage part marks, you can use your calculator. It is not an effect at all. Do not panic in exam to say, if the question is like this, I close my calculator and put it aside. No, 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 no. It works some more. You have to apply it, all right? Where you can, use it. But don't use it to simplify everything. All right, 4.2, we are given the square root of a minus 4, which is raised to the exponent of 2, plus the cube root of 8, everything over 2, which we can simplify in within minus when raised to an even power. I told you guys that it must change to a positive, right? So it's minus to the exponent of 2. It must be positive. Then 4 raised to the exponent of 2 is what? 16. So we're going to have a positive 16 plus, we do understand, guys, the cube root of 8 is what? Is 2. We can even use your calculator if you have forgotten that. But everything is over what? Everything is over these 2. So adding the numerator, because that's to be simplified, 16 plus 2, which is 18 over 2. So we can see that where we are, it becomes easier for us to simplify, because 18 divided by 2 is 9, and the square root of 9 is what? Is 3. We can also use the calculator to verify stages. Square root of 9, which is what? Which is a 3, in whatever part that you be given. Use your calculator, guys. Be with the calculator for the verification of what you are doing. All right, on question number 5, moving on, we are given simplify. 5.1, we are given 2p to the exponent of 0 minus the 2p in brackets to the exponent of 0. Yes, we do know every number raised to the power of 0 is 1. But be very careful on how the numbers are presented. So this p raised to the exponent of 0, this one, was going to give us a 1, which is very true. So it was going to be like this. It was going to be 2 times 1 minus the whole bracket here is raised to the exponent of 0. The whole bracket, the whole of it. So it gives us a 1. So that's it. 2 times 1, which is 2 minus 1, and 2 minus 1 is what? Is a 1. All right, 5.2, we can see that there are exponents that we need to consider. Negative, that's 5.2. We've got negative of negative mn cubed squared times minus mn raised to the exponent of 2, everything over minus m squared raised to the exponent of 3, n to the exponent of 10. So we can consider that, all right, this negative, guys, is out of the bracket of this one. So let's just write as it is. Whatever that we are going to have in this simplification of the bracket will be affected by this negative, which is this one out of the bracket. So it's up to you. You can open the bracket, or you just know, okay, it's totally out. So whatever that I'm getting is now affected by this negative. So that's negative raised to the exponent of 2, which gives us what? A positive. M raised to the exponent of 2, that's m squared. N to the exponent of 3 to the exponent of 2. Remember, you multiply. So 3 times 2 is going to give us what? A 6. So that was going to be minus m squared. N to the exponent of 6. Remember, there's a plus. So it will like minus and a plus will give us what? A minus at the end. All right. So that was it on simplifying this one times minus raised to the exponent of an even number. Remember, it gives us what? A positive. So it means we're going to raise m to the exponent of 2 and also n to the exponent of 2. Everything over negative when raised to an odd number, it remains as a negative, does not change. Take note. All right. Then here, multiply exponent, m to the exponent of 6, n to the exponent of 10. So that is where we are. And at this stage, we can figure out that it is a multiplication, which is very true. So we can consider the laws. Some of these guys, you can even cancel if you see them, but it's not a problem. You can consider the laws. Remember, I talked about these laws previously. If you're multiplying same bases, you add the exponents. So there's already a minus, but we must add the exponents 2 plus 2, which is under m. That was 4. N to the exponent, we add 6 plus 2, which is what? Which is 8. Everything, the denominator as it is. As it is. All right. So that was going to give us what? Negative, negative cancels. Division, I talked about this. We divide when we are dividing, we subtract the exponents. So it was going to be m raised to the exponent of 4 minus 6. 4 minus 6, that is a negative 2. Any, the same thing again, any to the exponent of 8 minus 10. We are subtracting the exponents. So 8 minus 10, that's a negative 2. That's it. We're done. Yes, we can get rid of the negative. Remember, x to the exponent of negative a is same as 1 over x to the exponent of a. We can get rid of that by writing it as 1 over. Since both are having negative exponents, it means both are in the denominator, raised to the exponent of 2 without the negative. That is the condition. That is the condition. So I want you guys to go through as many questions as you can as an individual. Try to understand. So 6 marks, guys, actually it deserves 6 marks. As you can see, the simplification was straightforward for someone who is into exponents. But if you are struggling with these questions, please do make sure that you go through the introductions, especially the basics from your grade 8, depending with the time that you are making your revisions. Some of you revise a day before. It means it can be difficult to go through those. But let's see, 5.3, we are asked again to simplify. We are still on simplify. So we have to ask ourselves here, because this type of equation, it was mixed, work with exponents. Now we are into algebraic expressions on the same question. So figure out on those algebraic expressions, what is it that they want you to simplify? You are given two brackets, 5.3 raised to the exponent of 3, it means y plus 9. To the exponent of 2, it means there are two brackets, y plus 9 into y plus 9. Minus these two brackets again, y plus 2 into y minus 5. That is the question there. Y plus 9 is squared. It is just like 3 squared. 3 times 3. So when a bracket is raised to the exponent of 2, it does not mean you raise it y squared plus 9 squared. No, this is totally wrong. It means multiply the two brackets, multiply the bracket by itself. So that is what we're going to have. So let us expand, guys. Remember, from your FOIL method, all right? So you're going to multiply y times y, which was going to give us y squared, then y times 9, which was going to give us positive 9y. All right, we are done with y there. We move on to positive 9. Positive 9 times y was going to be positive 9y. All right, positive 9 times a positive 9. Positive, positive. That's a positive. 9 times 9, which is 81. So we are done with the expansion of the first two brackets. We move on to these two brackets. So the minus, yes, you can use it to expand one bracket if you want. Or you can ignore this minus and expand the two brackets, these two. Whatever that you get, you use the negative later. You use it later. So just like what we had from the previous, going to multiply y times y here, which is y squared. Then y multiplies the minus 5, which is minus 5y. We're done. We move on to positive 2. Positive 2 times y, that's positive 2y. All right, so that's positive 2y, this one. Positive 2 and negative 10, and negative 5, sorry, 2 times negative 5. That's negative 10. I'm like giving you the answer already while I'm working on the question. Anyways, let's see, guys, what was going to happen by collecting like terms. On this part, we were going to have y squared. As we can see, I've got like terms here, 9y and 9y. So adding 9 plus 9, that's 18. So you're going to have 18y. All right, so this was going to be 18y plus 81. Moving on to this, remember the minus is there to expand the answer, so we can even ignore it until we get rid of this bracket simplified, right? So also we've got like terms in between these two terms, y and y there. So minus 5 plus 2 is minus 3. From our calculator, we can get minus 3 there. You can use your calculator. Minus 5 plus what? Plus 2, which is what? A negative 3. All right, then from there, we can use the negative. All right, we can use this negative now to expand the bracket. Remember, I said we could have used it here. We could even have used it in the first place here, this negative. So it is up to you where to use, but be very careful on how you use that negative. All right, so let's expand now with the negative. So negative times y squared, that's negative y squared. Negative times negative. Negative, when it meets a negative, becomes positive. All right, negative to negative 10, that's positive 10. So there we are. Let us collect the like terms and see what we are going to have. As you can see, guys, here y squared and y squared is totally out. They are the same, so they can cancel. Let's move on to, there is 18y here and 3y here. So these are like terms. So we can add 18 plus 3. 18 plus 3, which is 21. All right. Then moving on to the part of the numbers, 81, the constants, 81 and 10. We can add these two. 81 plus 10, which is what? 91. So it was going to give us a 91 at the end. So this is it, guys. 21y plus 91. It cannot be simplified further from here. We're just going to leave our answer as it is. So that was the simplification, guys, of question 5.3. We had to expand the brackets and collect the like terms. All right, that was it. Then moving on to question 6, factorization. Factorization. So factorize this part that we are given. Let's see what we are given here that we need to factorize. Remember, that's 2 marks, all right? So remember your factorization, guys. If we are asked to factorize, we have to check for the highest common factor. There are 3 terms. So what is the highest common factor of these terms? There is 8, 12, and 16. We do understand 8, 12, 16. You can consider those HCF, whatever, as product of its prime factors. Then you find the highest common factor, guys. But you're going to see the answer is what? Is 4. So in terms of the numbers, we're going to take a 4 as our highest common factor. We have got a 4. Then in terms of the letters, there is X, there is X, there is X. Remember the highest common factor I told you guys, when it is common, it must be common first. Then you take the one that has got the lowest or the smallest power. So that was going to be this one of what? X squared. So it was going to be 4x squared. Then we move on to the part of Y. There is a Y here, another one here, another one here. But we want with the one with the smallest exponent. So that is Y to the exponent of 3. All right, so we have got our highest common factor. With this highest common factor, we are now going to divide each term to that highest common factor to have what is remaining in the bracket. So it's like just each and every term, guys. You take each term, this one divided to this. So it's 8x to the exponent of 4, y to the exponent of 3, as it is this one, over what? What you factored out, 4x squared, y to the exponent of 3. So this was going to cancel because they are the same. 4 into 4 is 1 into 8, that is 2. Here, guys, we can see there are 2 x's. Here, how many are going to remain? 2, because they are 4. So it was going to give us 2x squared. So this is what we are getting inside of the bracket. The first term was going to give us 2x squared. All right. We do the same thing, guys. The second term to this term that we factored out, minus 12x cubed, y to the exponent of 4, as it is, to what you factored out, 4x squared, y cubed. Each and every term. So actually, by just looking at it, there's no need for us to do this, guys. 4 into minus 12, that's minus 3. 2 x's, yeah, there are 3, so they divide, we remain with 1 x. Yeah, there are 3 y's, yeah, there are 4, so you're going to remain with 1 y there. So it was going to give us minus 3xy. So moving on to this, also divided to this, 16x squared y5 over 4x squared y3. 4 into 16, that's a 4. X squared and x squared are the same, can cancel. There are 3 y's, here there are 5. So meaning to say we're going to remain with 2 y's on top. So that's 4y squared that we're going to have. So that's it, we are done. Factorize, we factored out the highest common factor, then divided each and every term. Each and every term. That is the most important part. Each and every term to the highest common factor. So like I said, if you know, guys, you won't be going all these. I'm going to try by all means to have more questions on your factorization so that it becomes more easier, more easier. All right, 6.12. We are given to factorize again a squared minus, all right, that was a mistake here. It was supposed to be 5a minus 6. All right, anyways, remember this is a quadratic dealing with the trinomials. where we've got a squared. To get the a squared, it means you have got a, you have got a. A times a is a squared. Then I told you guys, you focus with the constant -6. You ask yourself, what are the factors or the products, two factors or what? Products of -6. Two numbers that you multiply those two numbers, they give you -6. There are so many, -6 and 1, 6 and -1, 3 and -2. We can also have -3 and 2. There are so many. But of these numbers, which one, when we add, which one of these pairs that we have here, when we add, we must get a -5 here, -5. Where is it that when we add now, we must get a -5? So if we add here, we are not going to get a -5 is totally out. It's going to give us a -1. If we add, we're going to get a 1 is totally out. If we add, we're going to get a +5 is totally out. If we add here, we're going to get a -5. -6 plus 1, that's a -5. Guys, know your directed numbers also. So these are the numbers that we want. -6 and what? And a 1. No directed numbers also. No factors also. As an individual, if you know these things, it will be very, very easy to answer these questions. All right, moving on to 6.13. C squared -64. Factorize. This is a difference of two squares. Remember, 64 is same as 8 squared. And we understand that a squared minus b squared gives us what? A minus b into a plus b. What is being raised to the exponent of 2? It's a c and what? 8. So one must subtract, one must add c and 8. Guys, I don't know if we are together. Or simply determine what? The square root. The square root of c squared is c. The square root of 64 is what? 8. So one subtracts, one adds. The order does not matter which one starts. The order does not matter. You can start with addition. It does not matter. 6.3, simplify this. All right, more of your factorization there. So you can see that there's a multiplication. Here there's a division. So I'm going to get rid of the division. All right, so this was 5 marks so that we can just try to enlarge so that we can see this properly. So this is it here. So like I was saying, there is already, all right, sorry for that. There is already a division. So we have to get rid of this division. Introduce multiplication. So remember, how do we introduce this? 3y plus 6, y squared plus y minus 6 times, it's already under a multiplication, this one. So we're not going to change anything. Just rewrite as it is. We're going to do the factorizations later. All right. There the case is, there is a division. We must introduce a multiplication. But for us to do it, we interchange the following fraction. We change the denominator to go to the numerator, y squared minus 1 over what? The numerator to the what? Denominator, y plus 1. That is the case. Once you introduce a multiplication, it changes. So once you have got this, guys, simply factorize. Simply factorize, cancel whatever that you can cancel. The first part, 3 is common. So factor that, 3 and 3, that's going to be y there. 6 divided by 3, that's a 2. Remember, I talked about this type of factorization where we have got a y squared. We must have y and y here. Then we focus with the factors of what? The constant, which is the -6. So we talked of the factors of -6. It's a repetition. We talked about this, guys, -6 and 1, 6 and -1. We talked of 3 and -2, -3 and 2. But this time, when we add them, we must get here the coefficient of y, which is what? Which is +1. Of all the factors of 6, which part, when we add, we get a 1? Yes, totally out. Here, we're going to get a -1, but here, if we add, we're going to get a +1. So that's a 3 and a -2. a positive 3, and a minus 2. So that is it here, guys. Yeah, I'm just doing revisions, guys. I'm not teaching you a topic. Like I said, go through the introductions if the topic is still giving you challenges or a headache. But if you also have challenges, guys, let's communicate on the comment section so that I can do more questions on that one. Y minus 2 is totally in simplest form. The same with this one. There's nothing that you can do on these ones. They are in the simplest form. All right, y squared minus 1, that's a difference of 2 squares because 1 is same as 1 squared. So I talked about the difference of 2 squares where we subtract and another bracket we'll add. All right, y plus 1 already in simplest form. There's nothing that we can do. So once you have, or once you are at this stage, be very careful because you are going to cancel, yes, but which part do we cancel and how? The relationship is always the numerator to the denominator for us to cancel, like a 3 in the numerator, canceling a 3 in the denominator. It does not matter. It's from which fraction to which fraction. As long one is in the numerator and the other one is in the denominator, and they are the same, we can cancel. Such as y minus 2, y minus 2. We can cancel those. Y plus 1, we can cancel. So on y plus 1, there's another y plus 1. We cannot cancel this because it's already taken. All right. So as you can see, there is nothing left which is common. The numerator, there is nothing left that is common compared with the denominators. So what do? We take what is remaining in the numerators. So from the numerator, what is remaining? We have got y plus 2 here, y minus 1. What about in the denominators? Y plus 3 is remaining and y plus 1. These two, they did not cancel to anything. So they remain as they are. We cannot cancel. We cannot simplify further. Do not fight with the question. Just leave as it is. You're done. Unless everything is the same, we can cancel. All right. So they give us tempting questions also under exam. They know some of us here, you'll be tempted to be canceling y and y, y and y. No, don't do that. All right. So that is it, guys. Let us move on to another part. Without using a calculator, determine the value of on 6.3. What is it that we are supposed to use? Because the calculator could have simplified this and gave us the answer. 133 to the exponent of 2 minus 132 to the exponent of 2. We get an answer of 256. But they don't want us to do that. So how do I simplify when it is like that? 133 to the exponent of 2 minus 132 to the exponent of 2. It is the same as our difference of 2 squares, which gave us a minus b into a plus b. There is no difference there. Only that these are numbers. These are letters. That is the only difference. So if we were going to have a minus b, what is representing a this side? What is representing b? That is the case. So it was going to be 133 minus 132 times a bracket of what? A plus b. 133 plus 132. Just like that. So meaning to say, we are going to have what at the end? We can simplify 133 minus 132. Guys, here we know there's a difference of what? This one, 3. So that's 1. So that is 1 times, you add these. Guys, when they say do not use a calculator, don't also go to that level of not allowing yourself to add these two. No, guys, use your calculator there. You get what? 265. When they say do not use a calculator, they mean that on this part as it is, you just take this part as it is. Here you use it on the calculator. No. But on the simplification, guys, you can even add on the calculator. No one is going to know that. 1 times any number, we know that number remains as it is. 1 times x is x. 1 times 2 is 2. So 1 times 256 is 256. just like that. So this is what we're going to have. Solve the following equations. These are equations that we are given on question number 7. So the first one, 7.1, we are given, let's consider the first equation. 2x minus 3 is equal to negative 7. Taking the negative 3, this is a linear equation, guys. So you know that once it jumps the equal sign, it must change the sign. A minus 3 crosses the equal sign. Wherever it goes, the sign must change. Jumps the equal sign. So meaning to say 2x is equal to what? Minus 7 plus 3, which is minus 4. So simply divide by a 2. That was going to give us a negative 2 on this part. All right, 7.2, we are given two brackets that are equal to 0. It is not the first type that we are seeing. We dealt with this type of equation before. The zero product, guys. Once you see this, one of these brackets must be equal to 0. So meaning to say p minus 9 is equal to 0, or p plus 4 is equal to 0. I talked about this. So p is equal to what? Minus 9 to the other side, we add. So it's 0 plus 9, which is what? Which is 9. Or our p is equal to, the 4 jumps the equal sign. It changes. It's now a negative. So it's 0 minus 4, which is minus 4. So these are the possible values of p. Moving on to 7.3, we are given 5 to the exponent of m minus 1 equal to 125. This is an equation under exponents, exponential equations. We understand that if the bases are the same, the exponents can also be equated. So the question is, in the base of 5, 125 is same as what? That's 5 to the exponent of 3. Guys, yes, you can use your calculator. Some of you guys, 125 is equal to what? You equate, you put the equal sign there, then shift fact. It gives you the answer, 5 to the exponent of 3. Some of you are used to calculator. Use your calculator. Don't worry. Don't even worry. When the bases are the same, as we can see, we can cancel, or you can just get rid of that because we know that they are the same. What is important is that the bases are the same. So therefore, the exponents are also the same, guys. It's not like we're going to cancel to say it does not make. No. Guys, do not even worry about that. Do not even worry about that. Equate the exponents. You are done. It's an equation that we formed different to what we had. It's a linear equation, which we can take the minus 1 to the other side, so that once it crosses the equal sign, it changes the sign. So it will be 3 plus 1. So m is equal to what? 4. Just like that. All right, just like that. Determine the value of this on question number 8. If k is equal to 6 and L is equal to 8. So this is the square root. In place of k, put a 6. That's what they say. So it's 6 squared plus L squared. In place of L, put 8. 8 squared. Yes, we know, guys. You can use your calculators. You guys, but use it stage by stage, not like this, you get your answer. No. If you want to use your calculator, therefore use it stage by stage. 6 squared, you can use your calculator. It's 36 plus 80 squared, it's 64. We add 36 plus 64, which is what? 100. What is the square root of 100? The square root of 100 is what? Is a 10. Do not worry about plus or minus. Just a 10 like that. It is enough in our presentation. So this is it, guys, in our revisions. Let us continue to revise as many questions as we can, as we shine in light, preparing ourselves for the exams or for the tests which are ahead of time. Like I said, depending on the province that you are from, questions are still the same because we are working with the same annual teaching plan, the ATP. It gives, or it gets you back to know exactly what is in your syllabus according to your term 2 and term 1, as these tests are going to be covering term 1, term 2 work. So let's revise as many questions as we can till we meet again.